Hi everyone, this is Vijayasri, working as an assistant professor under the Department of CSIT, MLR Institute of Technology. In this session, we are going to discuss about what is algorithm and its characteristics, constituents of algorithm and flowchart. Algorithm and its characteristics. It is a step-by-step procedure or instruction which are used for solving a problem. An algorithm is a set of instructions designed to perform a specific task. Algorithm should be most effective among many different ways to solve a problem. Designing an algorithm. We can say an algorithm is a plan or a step-by-step procedure for solving a problem. These are the characteristics of an algorithm. First one is clear and unambiguous. An algorithm must be clear and unambiguous. That means the steps, whatever we are using in algorithm, inputs and outputs must be clear and that lead to one meaning. Input. An algorithm should have 0 or more well-defined inputs. Output. An algorithm should have 1 or more well-defined outputs. Finiteness. An algorithm must terminate an countable number of steps. Feasible. Algorithm must be feasible with all the available resources. Independent. Algorithm must be independent of any programming code. Let's go with the example. First one is how to prepare a tea. To prepare a tea, the output is a cup of tea and the inputs are kettle, milk, tea powder, then sugar, cup. Step 1 is start. Put the tea bag in a bag. Put the tea bag in a cup. Fill the kettle with water. Boil the water in a kettle. Pour some of the boiled water in a cup. Then add milk. Add sugar. Stir the tea. Tea is ready. Then stop. Let's go with the example 2. Addition of two numbers. Step 1. Start. Declare variables to add two numbers. We need number 1 and number 2. The result of addition of those two numbers must be stored in the another variable, that is sum. Here, read values number 1 and 2, add number 1 and 2 and assign the result to sum. So, sum is equal to number 1 plus number 2, display sum, then stop. Flowchart. Flowchart is a diagrammatic representation of an algorithm and these are the different symbols which we are using in a flowchart. The symbol is used for start and stop, which is called oval, and this is input and output, which is a parallelogram, and this is the process box used for calculations, and we can say it is also a sign box. Then decision, which is used for yes or no. Then this is the arrow which is used to show relationships. Then constituents of algorithm. There are 3 basic building blocks for constituents of algorithm for designing an algorithm. Those are sequence, selection, branching. Sequence, selection or branching, repetition or loops. Then, in constituents algorithm, the first one is sequence. Sequence, it is a series of steps that what we follow in an algorithm without any break. In flowchart, sequence of the statements usually contained in a rectangular process box. And when we are writing an algorithm, make sure that the steps are presented in a correct order. That means a series of steps that we perform. Algorithm for area of a circle under a sequence. Step 1. Start. Take input as radius. Then to calculate area of a circle, we know area is equal to pi r square. Pi value is 3.14 into r. Then display area, stop. So first for main, we use a symbol in a flowchart called oval. Then r we are considering as a integer type. So integer r we have to declare. Then area will get in a float value, that is 3.14, because pi value is here 3.14. So area is declared as a real. Then input is r. Then area is equal to 3.14 r into r. Output is represented in the symbol parallelogram output area. Coming to test cases, here r value is 2, then R is assigned in the formula 3.14 into R into R. Then we'll get area as 12.56. Selection. The next constituent of algorithm is selection. Selection is also called as branching. When designing algorithm, there are many steps where decision has to be made. Selection is a decision or a condition. Depending on the condition given, the algorithm will follow certain steps and ignore the others. Coming to this, we are going with an example called is person eligible to vote or not. First, step 1 is start. Then we'll give input as the person's age. Then if the person's age is greater than or equal to 18, then he is eligible to vote. If not eligible to vote. Coming to flow chart, start is represented in the symbol oval. Then here we are taking person's age as integer type. So here we have to declare that. Then input is represented in the symbol parallelogram. When the person is eligible to vote when his age is greater than or equal to 18. Coming to first test case, here the input is 20. So 20 greater than or equal to 18. Yes, condition is true. So true block is executed. The person eligible to vote in the test case 1. Coming to test case 2, here we consider person's age as 17. So his age is 17. Is 17 greater than or equal to 18? No, condition false. So the control goes to the false block. Then output is represented in the flowchart symbol parallelogram. 17 greater than or equal to 18 false. So the control goes to false block. Here person not eligible to vote is executed. Then the third constituent of algorithm is repetition. Repetition is also known as iteration or we can say loops. When designing algorithm, there are many steps that need to be repeated. This is known as iteration and it is displayed in a flowchart using a symbol hexagon. Iteration is a programming, means repeating the loops or instructions over and over again. This is often called as a loop. Algorithm consists of instructions that are carried out, performed one after the other. Sometimes an algorithm needs to repeat certain steps until a condition has been met. Under this repetition, we are going with an example, sum of individual digits of a given number. Let us suppose, if we take a number 123, the sum of this is 1 plus 2 plus 3 is equal to 6. Then for this algorithm, step 1, start, input is number, is in sum equal to 0, then we have to check the condition whether n is greater than 0 or not. If it is true, we have to find out the remainder, then sum is equal to sum plus remainder, n is equal to n by 10. Finally, print sum and then stop. Coming to flow chart, start is represented in the symbol oval. Then here n is specified in the data type integer, sum and remainder. Here n value is 123. So initially sum is assigned to 0. Now if we go with the condition, n value is 123. 123 greater than 0. Yes, condition is true. If the condition is true, the control goes to the true block. In that, we have to calculate remainder. Remainder is equal to n modulus 10. That is 123 modulus 10. 123 modulus 10 is 3. Then the remainder is 3 in the first iteration. Then sum is equal to sum plus remainder. Sum initial value is 0. 0 plus remainder is 3. So it is 3. In the first iteration, sum value is 3. Then we have to find out n. N is equal to n by 10. Here n is 123. 123 by 10, that is 12. Why we are finding n means we have to get the next individual digit from the number. So that we need a n value. Now 12, we'll check in the condition. In the second iteration, 12, is 12 greater than 0? Yes, condition is true. Again we have to calculate the, so the control goes to true block. So we have to calculate the remainder, that is n modulus 10. Here n is 12, 12 modulus 10. Yes, so it will give you the remainder 2. Already in first iteration, sum value is 3. In the second iteration, we'll get remainder as 2. So here in the sequence, we have sum is equal to sum plus remainder. Already in sum, we have 3. Then the remainder is 2. 3 plus 2, that is 5. In the second iteration, sum value is 5. Now, n is equal to n by 10. In the second iteration, n value is 12. So, 12 by 10, so it is 1. In the second iteration, n value becomes 1. So, now we'll check 1 in the condition 1 greater than 0. Yes, condition is true. So, again we have to find out the remainder because the control goes to the true block. The third iteration 1 greater than 0 condition is true. So, we have to find out the remainder 1 modulus 10. 1 modulus 10 is 1. So, the remainder is 1. Sum is equal to sum plus remainder. Already in the second iteration we have sum 5. So, sum plus remainder. In the third iteration sum value is 1. 5 plus 1, that is 6. Now, n is equal to n by 10. We have to check this condition till the condition is false. Now, n value is 1 by 10. So, the n value is 0. 0, we'll check in the condition, is 0 greater than 0? No. In this, the condition becomes false. So, the control does not enter into the true block, it comes to the false, and then we have to print the output. Here, we'll get the output as sum. Sum we have 3 plus 2 plus 1, that is 6. So, we'll print the output sum and then end. Output sum is represented in the flowchart symbol parallelogram, then end is represented in the symbol oval. In today's session, we have learned algorithm and its characteristics, then constituents of algorithm, in that sequence, selection, repetition, then flowchart with examples. In the next session, we'll learn structure of C program. Thank you.